Welcome back. Today we're going to talk about linear differential equations. So our main focus would be today on only linear equations. So linear equation basically has the form of y prime, which sometimes they write dy over dx, plus a function of x multiplied by y equal to another function of x. These functions of x could be constant or zero, assuming p is not zero. If p is zero, then you have y prime equal to qx, which basically you can find y. So it's not going to be a differential equation. It would be just simply an equation that you can integrate and calculate the result. So our assumption is that the px function is non-zero. So we have a differential equation. The idea to solve a linear differential equation is basically using the integrating factor. What is the integrating factor? If you write a differential equation in this standard form, the px function, this px function is basically kind of becomes involved in the integration at some point. So let's say I'm going to show you the idea of what does this integration factor do. First, if you have the integral of px dx, and I ask you find the derivative of this integration. If I ask you to find the derivative d over dx, what happens is the result would be the derivative of an integral, which basically becomes the px function. Okay, so if you integrate, then take a derivative, you should get the same function inside. Then what if we have e to the power integral of px dx? And now if I ask you what is the derivative of this term, the answer would be simply, if you have dealing with exponential function, then derivative would be e to the power of that exponent. The derivative of exponential would be the same, multiplied by the chain rule, the derivative of the exponent. But what is the derivative of the exponent? We already discussed that. The derivative of the exponent would be simply px. So I should say multiply by px. This is the derivative of e to the power integral of px dx. This integral of px dx would simply be a function. So why do we have this integration factor? If you look at the linear equation, if you multiply this linear equation on both sides by e to the power integral of px dx, multiply both sides by this integration factor, e to the power integral of px dx. What do I get on the left side? It would be basically, I'll write it with the color blue, you will have e to the power integral of px dx times y prime plus e to the power integral of px dx times pxy. On the right side you have this qx function multiplied by e to the power integral of px dx. Our main focus would be on the left side. If you look at the left side, what is this term? As you notice, that is exactly what we got here on the right hand side, which basically tells you if I call this integration factor something like I, what do I have is I times y prime plus this term would be derivative of I, so I prime times y. And on the right side you have qx times I. Okay, what I'm going to focus is on the left side. What is this remind you of? This is basically the product rule. If you have I times y and I ask you to take the derivative of the first one multiplied by the second plus the first one multiplied by the derivative of the second. On the right side you have qx times I. And what would be now if I integrate both sides? If I integrate both sides of this equality. What do I get on the left side is integral, and derivative will be opposite operation. So basically you would have I times y equal to integral of qx times I. And if I'm looking for y, I can simply, after calculating this integral of qx times I can divide both sides by I. I can divide this I into the denominator. This I is a function, so basically means at the end I can find the function of x by saying it would be the integral of qx times e to the power integral of px dx, and divided by I, which is the integral of e to the power the integral of px dx. You don't need to memorize the formula. You can go through step by step and always calculate this. But if you know the formula, you can always use this formula to calculate the result of a linear equation. What you need to figure out is first the integral of px dx, then replace it in this equation and calculate the integral of qx times the e to the power. I'm going to show you in both ways, using the integral or going back through the step. So let's start doing it through step by step. Here, given an example, and the question is, let me shift this up a bit. The question is solve this linear equation, and you always check to see if it's in the form of y prime plus px y equal to qx. If it's not in this format, you kind of have to rewrite it in this format to make sense of what is px, what is qx. Then you can replace it into the equation here. At the moment, I'm not going to use the equation. I'm going to simply go through the process. So what is px? Px for our example, this is, let me choose a different color, red. This is y prime plus 3x squared times y equals 6x squared. So if you compare, what is px? Px is simply 3x squared, and this is our px, a function of x, and qx would be 6x squared. Then, what is the integration factor? So that integration factor, which is e to the power the integral of px dx. So first I need to find out what is the integral of px dx. So what is the integral of px dx? It would be the integral of 3x squared dx, and this is simply x cubed. So that means our integration factor is e to the power x cubed. So what we can do is, again, we can multiply, by the way, it is better to write here this integration factor ix to show that we are using a function of x. It's not necessary to write it, but it's good to use the x notation. Okay, so what we can do is we multiply this integration factor on both sides of the equation. So if I multiply that to both sides of the equation, what do I get is on the left side I will get e to the power x cubed times y prime plus 3x squared e to the power x cubed times y, and on the right hand side I get 6x squared e to the power x cubed. Then this left hand side basically could be written as e to the power x cubed times y derivative. Because if you do the product rule, what would be the product rule? It would be derivative of that multiplied by y, and derivative of y multiplied by e to the power x cubed. Derivative of e to the power x cubed would be e to the power x cubed times 3x squared. So this is basically that derivative of e to the x cubed. So this is basically written it in terms of product rule. On the right hand side, what we have is 6x squared e to the power x cubed. So now if I integrate both sides, what do I get? On the left hand side, integral and the derivative, they can cancel out. You'll get e to the power x cubed times y. And on the right hand side, what we have is the integral of 6x squared e to the x cubed dx. So when you integrate, you always have to add this dx. Maybe on the left hand side I have a prime here, so it will create a dx for us. So now what is this integral on the right hand side? The integral on the right hand side will be simply, you can use a substitution. Here, let me calculate that on the right. 6x squared e to the x cubed. If I use substitution and say I call u to be x cubed, then du equals 3x squared du over dx, which you can multiply the dx to the other side. Dx would be simply du divided by 3x squared. So this can be written as 6x squared multiplied by e to the power u multiplied by du over 3x squared. And after simplifying, these two can cancel out and you will end up with a 2 here. So this becomes 2 integral of e to the u, which is basically 2 e to the u plus some constancy. And u was x cubed. So I can replace it back and say this is 2 e to the x cubed plus some constancy. This is simple integration. So the right hand side would be simplified to 2 e to the x cubed plus some constancy. And then how do I find the y function? Divide both sides by e to the power x cubed. Divide by e to the power x cubed. And you can simplify it and write it as y equals, you should write actually y of x, function of x, if you want to write in terms of function of x, or maybe just write y is okay too. These two can cancel out, you'll get 2, c divided by that could be written as c e to the power negative x cubed. So we found this as our solution for the function y of x. At the end, maybe you can write that. And if you replace this back into the equation, it should satisfy the linear equation. You can always double check and go back, replace it in this equation to make sure that is the solution. So this is the process that you need to go through to find this solution. But you can use this highlighted section to the solutions of linear equation. You can simply skip ahead and go use this. So the steps to use that, so here maybe I should mention it. You can do that step by step, which is a better choice, but if you don't do that and you want to go through this formula, y equals to integral of qx multiplied by e to the power integral of px dx divided by e to the power integral of px dx. This is our integration factor. So step 1 would be basically write the equation in terms of y plus px times y prime equal to qx. Basically figure out what is px, what is qx. Then step 2 would be to find what is px, what is the integration factor, what is the integral of e to the power px dx. We need to figure out what is that. E to the power. First find this integral px dx. Then step 3 would be find e to the power integral of px dx. Step 4 would be basically calculate the integral of qx multiply by whatever we found here. Let me call it ix. So multiply by ix and calculate this integral. And finally at step 5, you can write y equals to the integral of the result of this integral qx times ix divided by ix. This is basically the steps to calculate this, the solution to a linear equation. So here, for example, I'm going to use that in this example just to show you both methods. Both are correct. You don't need to necessarily choose one over the other. You can figure out which one is simpler for you. So in this case, you notice that it's not written in the form of y prime plus px y equal to qx. So what I'm going to do is first write in that format, which means I need to divide everything by the coefficient of y prime to get rid of the x squared. So I'll divide an x squared, divide an x squared, divide an x squared. By doing this, I can write this equation in terms of y prime plus x squared, x divided by x squared would be 1 over x, y equal 1 over x squared. And now I have px equals 1 over x and qx equals 1 over x squared. By the way, this extra information given is at the end. You want to figure out what is this constant. If there is a constant somewhere, we just want to figure out what is that constant. So we're looking for a particular solution, not the general solution. In the last example, we found the general solution and it involved some constant. So here first, step 1 was to find that. Step 2 would be, to find the integral of px. So what would be, so this is step 1. Step 2 would be finding the integral of px dx, which basically is integral of 1 over x dx, and that is simply ln absolute value of x. With the assumption here given, you don't really need the absolute value. So I can say simply ln x. And then, since we're using it for the integration factor, there is no c here. This is used for the integration factor. So here, what I can write is, what I want to find in step 3 is the integration factor, which would be e to the power integral of px dx, which we found that already, e to the power ln x. And this could be simplified. What is e to the power ln x? Simply x. Those are inverses of each other, exponential and log. So step 3, we found the ix function. Step 4, we need to find the integral of qx times ix dx, which is the integral of qx was 1 over x squared multiplied by the ix function, x multiplied by dx. And this simply becomes 1 over x squared times x, which is 1 over x dx equal ln, again, you don't need the absolute value since x is positive, ln x. So this is step 4. Step 5, the solution. What is y of x? Y of x would be, here I should add a constant c, because this is our last integration, and it's not the integration factor. So ln x plus c, the qx ix integration, the result that we get here. Maybe I should write that, so make sure you guys are following the format. Qx times ix divided by the ix. You cannot cancel out the ix because first you have to calculate this integral, and that integral will be, in this case, what we found, ln x plus c, and then the ix function was simply x divided by x. So So this is our yx function. So I can say I found the yx function. It's simply ln x plus c divided by x. But now, given this particular information, y of 1 equal to 2, I can find out what is the constant c. So how do I find the constant c? I will use this, the fact that the y of, again, the y of 1 equals to 2. It means if you replace 1 for x, you should get 2. So I say y of 1 equals 2. This is given. So, which means if you replace 1 for x, I'll get 2 on the left side. On the right side, here. On the left side, I get 2. On the right side, I have ln 1 plus c divided by 1. What is ln 1? ln 1 is 0. So c simply becomes 2. This is 0. So you have c plus 0, which is c divided by 1. So c must be 2. And then I can write the general solution, the particular solution, y of x equals ln x plus 2 divided by x. And this is the particular solution to our linear equation. If you go through the process that we discussed earlier, if you go through this integration, factor multiplication and factoring out, then you integrate and stuff, you will get the same result. Try it through that method and make sure that you get the same result. Here, one more example. Again, either method is fine. You don't really need to be picky. Find out which one is much easier for you to do. Here, one more time, I can go through the integration factor. First, find out what is ix. I'm going to use the first method, which was e to the power integral of px dx. So what do I need? I need to figure out what is px, what is qx. In this case, it's given already. This is in the right format. This is our px, and here qx is simply 1. So what is the integral of px? So integral of 2x dx would be simply x squared. Then our integration factor would be e to the power x squared. Then I can multiply e to the power x squared on both sides of this equality. E to the power x squared y prime plus 2x e to the power x squared times y equals e to the power x squared. What do we get on the left side? On the left side, simply we get e to the power x squared times y derivative. And on the right hand side, I have e to the power x squared. Then an integral of left hand side, if you integrate both sides, on the left side we get simply e to the power x squared times y. On the right side I have integral of e to the x squared dx. I should actually add a dx here. So what we can do is we can try to calculate the integral of e to the power x squared dx, because we would need this. It turns out it's not always that easy to calculate the integral. So this is not something that we really went through it, but it's not possible to calculate this integral. So this is kind of not possible to find the general function. So what we can do is we can leave it as it is, and our solution would have a form that contains this integral. So what you can do is, not always you can find the integral, but you can try to simplify it and say, what is y of x? Y of x would be whatever that integral is, e to the power x squared dx divided by e to the power x squared. Again, you cannot cross these out because that's inside the integral. So we leave the solution as that format. And this e to the power x squared, and similarly something like e to the power negative x squared, this is not something that we can calculate. You cannot find, not possible to find the integral as a function. If there were boundaries, then there are tricks to calculate, but at the moment we don't know those. We have to need to talk about polar coordinates. So again, it's not always possible. Try substitution and other methods that you've learned, maybe to see if you can calculate this integral, but the idea is that it's not possible. So the techniques that we have learned so far, you cannot calculate these integrations. So I will leave it as it is, and I say my solution is in that format. In the other examples that we did, you can find the integral. Here the integration was possible. You can find the integral of 1 over x, for example. Okay, here's another example. Not always you get x and y. Sometimes you get u and t, or z and x, whatever. So here first you figure out what is the function. In our case is u is a function of t. So you have u of t. This is the question. Find out what is u of t. Then given the fact that u at 2 equals 4, then we need to find a particular solution. It's not written in the form that we want, this equation, in the linear format. So I'm going to do this. I'm going to write it as t times u prime equal to t squared plus 3u. And you notice that if you're not comfortable with u and t, you can always change it to x and y. You can write it as x times y prime equal x squared plus 3y. It's easier to notice x and y if, for some students, sometimes it's not that clear what are the variables and what is the function. So you can change it to x and y. Just make sure that you change all the u's to y, all the t's to x. Again, this is based on the derivative and the given information that I know u is a function of t. Okay, so either way is fine. You can stick with the x, you can stick with the t. I'm going to stick with the t, so I will move this 3u to the other side. I will have tu prime minus 3u equal t squared. Then I divide everything by t, because I want to have u prime by itself. U prime minus 3 over t, u equal t squared divided by t would be simply t. So I know what is px. This is my px. Actually, you should consider the negative sign with it. So this is the px. In this case, I should say p of t. And here I have q of t. Okay, then I'm gonna stick with the method that we know. We know that u of t would be, the solution is in the form of integral q of t times the ix it function divided by it function. And what is it function? It function is simply e to the power integral of p of t dt. So all those x's turn into t, all the y's turn into u in this case. So what do I need? I need to figure out what is the integral of pt, the it function. For that, I need to figure out what is the integral of p of t first. dt, sorry about that. This is integral of pt, which is negative 3 over t dt. That's nothing but negative 3 ln of t. And again, assumption t is given greater than 0, so that means you don't need the absolute value. If it was given t is less than 0, then you have to put an absolute value and change the t to negative t. Okay, ln t. So what would be the integration function? I of t would be e to the power negative 3 ln t. So how do you simplify this? You can write it as e to the power ln t, the whole thing to the power negative 3. It has the same meaning because you multiply the exponents. So what is this inside? That inside is e to the power ln t would be simply t. You have t to the negative 3. and that is the same as 1 over t cubed. So we found the integration factor, which is 1 over t cubed. Then what is the integral of q of t times it? And this is integral of q of t, which is 1 over, t. Here we have q of t, and multiply by 1 over t cubed dt. This is integral of 1 over t squared dt. I hope you all know that this is simply t to the power negative 2 dt. And you can add 1 to the exponent, subtract, you will get negative 1 over t plus some constant c as the result of our integration. Then what is the u of t finally? It would be the integration that we got from qt it, which is negative 1 over t plus some constant c, all divided by the I, which is 1 over t cubed. You can simplify it by simply multiplying a t cubed in the numerator and denominator to get rid of this t cubed here. Then t cubed times negative 1 over t would be simply negative t squared plus c times t cubed. And we found out what is u of t now. So u of t equal negative t squared plus ct cubed. In this case, since we are looking for a particular solution, we just need to replace 2 for t and figure out what is this constant c. So since given u is 4, when you replace t with positive 2, 2 squared plus c times 2 cubed. I can find out what is that constant c. So here you would have negative 2 squared, which is negative 4, so you'll get 8 equals c times 8, so therefore c must be 1. This tells me that the u of t must equal negative t squared plus, instead of c, I can replace 1 t cubed. And this is our general solution, our particular solution to the equation. There is no constant c involved anymore. And I think it is easier to go through the formula than going through every step every time, but by doing the steps after a while, you will get, you don't need to memorize the formula. That would be the good part, to try this method first for a while. Then after that, the steps to the calculation of the linear equation would be much faster and easier to remember. Okay, so that's it for today. I'm going to stop at this point.